Okay, so you guys, our very first lesson is going to be on numbers and number sets. So we always like to introduce math by talking about like what exactly is a number. You've learned about numbers ever since you were in kindergarten. You started counting in kindergarten, then you learned addition, subtraction, multiplication. But there's actually a very sophisticated way of grouping numbers together. And so that's what we're going to start talking about. And that's what this chart represents. The word that you give every single number on the planet is called a real number. There are a couple of exceptions that you'll learn way later in more sophisticated math courses. But for now, we're going to say every number that exists is called a real number. And then from that, you have 5 different categories, and I'm going to go over all 5 of those. So if you take a look at the very top box, it says rational numbers, and that is given a symbol of Q. Okay, so whenever you see the symbol Q, you're talking about a rational number. And a rational number is basically a number that can be written as the ratio of 2 integers where the denominator is never 0. What does that mean exactly? It means that every single rational number can be written as a fraction, like 3/4, -1/4, 5. By the way, if you have a whole number of 5, does anyone know how to make that into a fraction? Yeah, any whole number can actually be made into a fraction by just putting it over 1. The denominator will be a 1. Or for example, if I have 150, I can make that into a fraction by putting it as 150 over 1. But basically, every rational number can be written as a fraction as long as the denominator, this bottom number, is not a 0. If the bottom number is a 0, it's no longer a rational number. So rational numbers are Q. Irrational numbers are given the symbol P. And an irrational number is a number that cannot be written as the ratio of 2 integers. So there are certain numbers out there that you cannot write as a fraction. And by the way, they mean like putting it over 1 is not an option. So an actual fraction like 3/4 or 5/6. So a couple of examples of that are the number pi. Does anyone know the first couple of digits of pi? Yep. Yeah, sure. Sirsha? Where's my little pie chart that I had here? Oh, it fell. It was right over there. I swear I put it up yesterday. I don't know where it went. Yeah, you're right. You actually know a lot more than I do, but that was pretty impressive. So the number pi can never be made into a fraction. You can't just say it's like 8/20 or anything like that. Another example is the square root of 2. You can't make that into a fraction. Or usually an irrational number is a non-ending, non-repeating number. So it's sort of like a crazy number, like 1.8562893288857. So usually when it goes on forever and it looks super crazy, that is an irrational number. So a little hint for you is it's a non-ending, non-repeating number. I always like to think about like if someone is irrational, it means they're not like being very proper, I guess, or they're not thinking logically. So an irrational number is kind of like crazy, not very logical. Okay, the next number we're going to look at is a whole number. It's pretty easy to remember the symbol. It's given a symbol of W. And a whole number are all positive numbers from the number 0 all the way to infinity, not including fractions or decimals or negative numbers. So they're basically the very first number you learned when you were 2 years old and your parents were teaching you how to count. Those would be our whole numbers. So 0, 1, 2, 3, 4, 5, all the way to infinity. And by the way, infinity just means that there is no end to the number line. It just keeps on going forever and ever and ever. Okay, the next one to note is a natural number. And a natural number are all positive numbers from the number 1 to infinity, not including fractions, decimals, or negative numbers. What is the difference between a whole number and a natural number? It seems like it's the exact same definition, but there is one important difference. Yeah. Yeah, which one includes 0? Exactly. So the major difference is that a whole number will include the number 0 and a natural number will not include the number 0. How do I remember this? Well, I noticed that the word whole has the letter O, which kind of looks like a 0. And that for me is a reminder that whole numbers include 0. Natural numbers are everything from 1 to infinity, not including 0. So those ones are pretty easy to remember. All right, how about integers? Integers are all positive and negative whole numbers. So an integer will be something like -3, -2, -1, 0, 1, 2, 3. It doesn't include fractions. It doesn't include decimals. It doesn't include, it does include negative numbers, but there are no fractions and there are no fractions and there are no decimals. All right, guys. So if you turn to the next page, let's just take a look at this diagram and try to figure out what's happening here. It says it's a classification of real numbers. Label the diagram correctly with the following terms, and all of the 5 terms that I've taught that we've just learned are included at the top. So I want you to go ahead and try to label the circles with rational numbers, integers, whole numbers, natural numbers, and irrational numbers. So try to put one of those labels in every single one of the circles. Okay, so this is a pretty quick activity. What did you guys get for the little green circle? What do you think belongs in the green circle? Farabi? Did you say irrational? Yep, you're absolutely right. Can you tell me why you chose irrational to be here? Yeah, you can't make any of these numbers. You can't make any of them into fractions. And if you were to put them into a calculator, they would be very long, non-ending, non-repeating numbers, right? The square root of 72 would be a very long decimal number. You're right. How about for the big red large circle? What did you guys get for that? Nicole? Yep, and why did you pick rational? Yep, so they can definitely be made into fractions, every single one of these. And also, even if something, that little dash over the 3.56 means the number is actually 3.5656565656. It keeps repeating. And usually a repeating decimal like that can be made into a fraction. Good. What did you guys get for the purple circle? Abrami? Integers. And how did you know that that was integers? Yeah, they're all whole numbers. They don't have decimals. They don't have fractions, but they have negative signs. So they can't be natural numbers or whole numbers. They have to be integers. Good. All right, let's keep going. How about the blue circle, which just has the number 0? Sienna? Yep, and how did you know that was a whole number? It's the only one of the zeros. So remember, the word whole has a big O in it, which tells me that it includes the 0. And then last but not least, the littlest circle, what would that be? Jen? That would be natural numbers. And how did you know that was natural? Yep, exactly. So that's really it. I think sometimes when you see it in a diagram like that, it makes a lot more sense. And hopefully now you guys kind of understand the difference between these. And by the way, if I were to put a huge box around everything, and I were to say, okay, group every single one of these together, but let's change the color of the box. There we go. Oh, let's actually make it a yellow. What would you call every single one of these numbers? Yeah, Erie? They would all be called real numbers. Good job. So if you want, you can just make a note of that on your diagram as well. Okay, we're going to move on to the very last part of this lesson, and it's called special integers. What are special integers? They're probably things you may have heard about before. They are prime numbers, composite numbers, even numbers, odd numbers, and consecutive numbers. So I'll start with the easiest one, the word that you probably all know, and it is even numbers. The definition of an even number is it's a number that has 2 as a factor. If you're wondering what a factor means, it's just basically a multiple of it. So every even number can be divided by 2 very easily. And so that is what they mean by 2 as a factor. Another way to think about it is every even number ends in 0, 2, 4, 6, 8. Odd numbers are the other ones you probably are all familiar with. And that's any integer that does not have 2 as a factor. So if you were to take an odd number, you would never be able to divide it by 2 and get another whole number or an integer. You'd always get a decimal of some sort. And another way to think about odd numbers are they're all the numbers that end in 1, 3, 5, 7, 9. Consecutive numbers, that's just a fancy way of saying, tell me 3 numbers in a row, and you would say 60, 61, 62. Tell me 4 numbers in a row that are over 100, you would say 105, 106, 107, 108. So consecutive numbers are just numbers that are back to back to back. They have a difference of 1. So I started with the 3 that I know you're familiar with. Does anyone here know what a prime number is? Oh, I'm very impressed. Okay, let me try to say your names without my sheet. Oh, yours is Yishan.
Prime numbers, it can be only divided by 1.
Yeah, so the only factor a prime number has, the only multiple a prime number has is the number itself or the number 1. For example, if I gave you the number 13, I would ask you what numbers multiply to give you 13. You probably couldn't think of anything except 1 times 13. How about the number 23? Can you think of any 2 numbers that multiply to give you 23? Yeah, the only numbers are 1 times 23, and so it's a prime number. How about the number 30? Is 30 a prime number? Exactly. So if a number is not a prime number, then that's the second definition. It is a composite number. Any number that has multiple factors or multiple numbers that multiply together would be a composite number. Let's go back to 30. Can you guys tell me some numbers that multiply to give you 30? Abrami? 10 times. 10 times 3, perfect. Ari? 2 times 15, good. There's probably a few more. Swadhana? 5 times 6. And there's one more that we haven't said. Someone I haven't heard from. So I've heard from Nicole, I've heard from Shams, I've heard from, it's Farabi. Yep, Oscar? 1 times 30 would be the last factor. And so just know when we talk about factors, we're talking about all the numbers that multiply together. Any questions about that? Okay, so we wanted to ease you into this nice and slowly. What we're going to do is we're going to talk about this. I lied. There's a little bit more to it, and then we'll try to do a little bit of homework. Let me check on our... Okay, you guys, I don't know how you feel about little cute cartoon animals, but I love them. You're going to see them all over the place. I feel like they just make math a little bit happier because math for me is happy and cute little animals are happy. So you'll see them all over the place. Okay, the mathematician Owl is saying there are 3 other definitions we need to learn about, and they're all called density, infinity, and limit. Can I get a volunteer to read the definition of density so you don't have to hear me talk? Jen, go ahead. Oh, the blurb at the top of your sheet, just where the little owl is talking. If I gave you, thank you, if I gave you any 2 numbers, like 2 and 3, and I asked you to tell me 100 numbers in between those numbers, you would very easily be able to. You would say something like 2.1, 2.2, 2.3, 2.4, but then you can also say 2.21, 2.31, 2.41, but then you can also say 2.311, 2.31411. You can keep going and going. There is no stop to it. There is an infinite number of numbers. There has never been a stop to it, okay? So that's what is meant by density. Another volunteer to read infinity. Manat. Yeah, have you guys ever seen the infinity sign? Yeah. Oh, what car am I thinking of? There's something that has a popular brand has an infinity sign. Which one is it? The car, but isn't there another popular brand with this sign? Maybe I'm making something up. Okay. What the word infinity means is that there is no end to the number line. The numbers will keep on going forever. If you were to have a computer program, and by the way, you can look this up, there is a computer program that is counting the numbers from 0 to infinity. And basically, it's just like computing all of these numbers, and it just keeps on going forever and ever and ever. There's no end to it. What else can you describe as being infinite? There's something else that we sometimes say is infinite. Sirsha? No, but you're right. They say like space, they haven't seen an end to space. It just seems to keep on going forever and ever and ever. So that seems to be infinite. Good. The last one is a little bit harder to grasp. I'll try my best to explain it. Limit. Limit is the value that a pattern approaches. So for example, if I were to say, name every number up till the number 3, that means the limit that I'm setting is the number 3. I want you to stop at the number 3. So you could say 0, 1, 2, 2.1, 2.2, 2.3, 2.4, all the way to 2.9. Then you can say 2.99, 2.999. Of course, you'll never reach the number 3 because there's like an infinite number of numbers before you reach that limit. But I put a stop to the numbers, right? That is how you would describe a limit.
Okay, apparently we're being recorded now.
Yeah, you guys, we're gonna get started. So let's take some of these up. Can I get someone to tell me write 10 numbers between 2 and 3. What numbers did you guys write? Manat? Yeah, so I guess the easiest ones in this case would just be 2.1, 2.2, 2.3, et cetera, et cetera. Did anyone get a little creative with this and think of something else? No, everyone just picked the exact same ones. You could have also done 2.1, 2.11, 2.111, and just kept adding ones. You could have done the exact same thing with you could have done 2. I don't like when the colors are all the same. You could have also done 2.0001, 2.0002. So the possibilities are endless, and that's why it is said to have an infinite number of solutions. All right, good. Let's talk about infinity. Given 3 times n, and I know we haven't talked about algebra, we haven't talked about any of that. Hopefully, maybe you've learned that a letter just stands for a different number. What happens as this number over here gets larger and larger and larger? So like 3 times 1, 3 times 10, 3 times 100, 3 times 1,000. Sienna? Yep, exactly. So as the n gets larger and larger, we are approaching infinity. I mean, yeah, you can say it in any way that you like, which is fine. And Javint, I see you said it will go to infinity, which is perfect. How about if you have something like a half times n, and now n is getting larger and larger and larger? What do you think is going to happen to the number? Farabi? Say it again. Okay, so for example, if I did a half times 1,000, then a half times 10,000, or is that number still getting bigger and bigger and bigger? Yeah, so you're right. It would still approach infinity, but would it be as quickly as the number before? No, because you're actually keep dividing it in half, but it doesn't matter because as that n gets larger and larger and larger, it's still going to approach infinity.